Hi, this lesson is about inverse matrices and matrix multiplication. So first we have to define what the identity matrix is. So we're going to call the identity matrix I sub n, where the n represents an n by n matrix which has only ones on the diagonal from left to right and the rest of the entries are 0. So the identity matrix I sub 2 looks like this 2 by 2 matrix. And the identity matrix I sub 3 looks like this 3 by 3 matrix. So I sub 4 would be similar. It would have all ones on a diagonal from left to right, and the rest of the entries would be 0. So identity matrices behave like the number 1 in that when you multiply by 1, it doesn't change the identity of the number. So when you multiply a matrix by the identity matrix, you just get the original matrix back. And the same is true whether you multiply it in the other order. So in this case, with the identity matrix, it would be commutative, unlike when you're multiplying two different matrices where it's not an identity, it is not commutative. And so we talked about how to multiply matrices in the last section. So because there are rules in terms of your dimensions, if your matrix A is an m by n matrix, then the identity matrix has to be an n by n. Or if you are multiplying an identity matrix by a matrix here, a different matrix, then the matrix A must be an n by m. In other words, this dimension and this dimension has to always match when you are multiplying two matrices, even if it is an identity matrix. Okay, so in this this next statement says that if A and B are two square matrices with dimensions n by n, then if you multiply A and B or B and A, and your result is the identity matrix, then B and A must be inverse matrices of each other. So when that relationship exists, where their product becomes just the identity matrix, meaning it would look like something like that, then A and B are considered to be inverse matrices of each other. Okay, so specific notation regarding inverses. So if you have a matrix A, its inverse is A inverse. It's not A to the negative 1. So this is read as the inverse of A or A inverse. So again, just reiterating this, A times A inverse or A inverse times A would equal the identity matrix. Okay. Show that A and B are inverse functions, where A is the 2 by 2 matrix 2, 1, 5, 3, and B is the 2 by 2 matrix 3, negative 1, negative 5, 2. So what I'm going to do is I'm going to actually check, is A times B equal to I sub 2? Or you could do, is B times A equal to I sub 2? So I did it both ways. You only have to check it once. So A times B means that you're doing 2 and 1 multiplied by 3 and negative 5. So 2 times 3 is 6. 1 times negative 5 is negative 5. And when you add up that result, you get 1. Then you go to the next column. So 2 and 1 gets multiplied by the second column in matrix B. So 2 times negative 1 is negative 2, and 1 times 2 is 2, so that's where I get 0 from. So far, the first row looks good. And if you repeat that process using the second row, and then multiply by this, you'll get 0. And then 5 and 3, the second row gets multiplied by the second column, and you get 1. So your result is I sub 2. My diagonal has 1s in it, and the other entries are 0. So this result proves that A and B are inverses of each other. You could have done it in the other order, doing B times A. And so again, you would just do this row and this column. And if you do, you'd get the 1. And you would continue doing that process. And your result is, again, the identity matrix I sub 2. So either one of those exercises shows that your answer here is just I sub 2. So with 2 by 2 matrices, you can actually find what the inverse matrix is by using a formula. It's not quite as easy with 3 by 3 or 4 by 4 matrices, but with 2 by 2, we have this really nice convenient formula that allows us to solve for the inverse. So if A is some matrix A, B, C, D, then the inverse matrix will be 1 over AD minus BC times D, negative B, negative C, and A. So the A and the D switch order from where they were originally, and the B and the C just switch signs. So instead of it being BC, the B and the C stay in the same place, but you would take the opposite sign right here. So this exists as long as AD minus BC is not equal to 0, because if it is equal to 0, 1 over 0 is undefined, so you would not be able to compute the inverse, so because the inverse would not exist. So the inverse will exist as long as AD minus BC is not equal to 0. Okay, so let's use this formula. Find the inverse of B, where B is negative 3, 2, and 4, negative 1. So first I'm going to do 1 over AD minus BC. So that's 1 over negative 3 times negative 1 minus 2 times 4. And that I'll be able to simplify. And then I applied the second part of this formula, which is this. Switch the position of these two numbers. So the negative 1 goes in the upper left-hand corner. The negative 3 goes in the lower right-hand corner. And the other two numbers, the 2 and 4, are just going to switch signs. So instead of having 2 and 4, I'm going to have negative 2 and negative 4 in this next line. So this result works out to be 1 over negative 5. And now that 1 over negative 5 has to get distributed across this matrix. It's just multiplying by a scalar. So the inverse of B is 1/5, 2/5, and 4/5, 3/5. Okay. Then I checked it. I said, all right, if these two are actually inverses of each other, then this times this must equal the identity matrix. And once you do that operation, you do get that it is the identity matrix I sub 2. All right, another example of where we're finding the inverse is this one here below. A is equal to 7, 4, 3, 2. Again, applying the formula, it's 1 over 7 times 2 minus 4 times 3. These numbers on the diagonal switch position, so I get 2 and 7 there. And the other numbers just switch signs, so this one becomes negative 3 and negative 4. Then I just have to work out what that fraction is, and this becomes a half, and then a half has to get multiplied across all of this, so you get 1, negative 2, negative 3 halves, positive 7 halves. Okay, so when you have something larger than a 2 by 2, there is no formula. So with something like a 3 by 3, it is a bit more work to find what the inverse is. So to find the inverse of a 3 by 3, we must construct a matrix A, with the inverse matrix I sub 3 immediately to the right, which will essentially create a 3 by 6 matrix. So you're going to have 3 columns from the original matrix and 3 columns from the identity, which is why it then becomes a 3 by 6 matrix. Then you're going to do elementary row operations to make the left side look like the identity matrix. And whatever is left on the right side will be the identity of the original matrix. So here's an explanation of how to do that. So we want to find the inverse of this 3 by 3 matrix. So first you're going to copy all of this here. Then immediately to the right, I'm putting the identity matrix I sub 3. Ones on a diagonal, zeros everywhere else. This is just a dotted line separating the two. Then my goal is to make the left 3 rows look like the 3 rows on the right. So I want ones on a diagonal and the rest of the entries to be 0. And any operation I do to accomplish that must also be done on the right side. So the first thing I decided to do was to multiply row 1 by 2 and subtract row 2 in order to get a new row 2. And what that will do is we'll make this term 0. So row 1 and 3 simply get copied over, and row 2 is going to change. So when I do 2 times row 1 and subtract row 2, my new row 2 becomes 0, -1, -2, 2, -1, and 0. Notice the right side is changing, as well as the left side. Okay, so I still have quite a bit more to do because I need all diagonals of 1 and the rest of the entries all 0 in the first 3 rows and column. So the next thing I chose to do was to multiply row 1 by 3 and add it to row 3 to get a new row 3. So when I do that, this will get tripled. And when I add it to row 3, that term right there is going to turn to 0, which is what we want. But it actually accomplished more than that because this multiplied by 3 is -6. When I added to this, that one also turned to 0. So my new row 3 is exactly what you see there, 0, 0, 3, 3, 0, 1. So again, it's already looking better. This is a problem that you should expect would require a lot of space in your notebook. Now in this next operation, I'm going to do 2 things. So first I'll talk about the easier one. I'm going to multiply row 3 by 1/3 to make that into a 1. But I'm also going to try to accomplish something else, which is I'm going to multiply row 2 by -2 and add it to row 1 to get a new row 1. And what that will accomplish is that this term is going to turn to 0, but it also makes that one into a 0. So again, some of these are working out quite nicely in that I'm getting 2 things done with one operation. So my new row 1 is what you see here, 1, 0, 0, -3, 2, 0, and my new row 3, when I multiply by 1/3, is 0, 0, 1, 1, 0, 1/3. So the first 3 rows and columns are looking pretty good. The only thing I need is I need to make this one into a positive 1, and I need to make this one into a 0. Okay, so changing the -1 to a positive 1 is pretty easy. But to get rid of that -2, I'm going to multiply row 3 by 2 and add it to row 2. So when I double this becomes a 2. And so when I add it to this one, it will cancel it and it will become a 0. So again, copy the rows that are not changing. Only row 2 is changing. So row 1 and 3 get copied down. And my new row 2, when I do 2 times row 3 plus row 2, will become 0, -1, 0, 4, -1, 2/3. And then the last thing I need to do is to make this -1 into a positive. So I'm just going to multiply row 2 by -1. So I have now accomplished what my goal was to make the first three rows and columns, the first three columns look like the identity matrix. So that means that what's left on the right side is the inverse. So the inverse of A are the last three columns, which is negative through 3, 2, 0, -4, 1, -2/3, and 1, 0, 1/3. And again, if you weren't sure if you did it right, if A times A inverse equals I sub 3, then that would be your check. And it does work in this case. So that's how you find the inverse of a 3 by 3 or anything greater than a 2 by 2 can be accomplished with this method. As you can see, it's rather long and tedious. Okay, so here's one for you to try. The question is asking you to show that A and B are inverse matrices, where A is a 3 by 3 and B is a 3 by 3. So all you would need to do is multiply A and B, and if your answer is the 3 by 3 identity matrix, then you can say that yes, you have shown that the two are inverses of each other. So you can give that a try. Good luck.